Our today's topic is chemical oxygen demand. What is this chemical oxygen demand? Why should we determine COD or BOD of any water sample? Why is it essential? Why? Because just a couple of years back, you might have seen in our newspaper, or we have read about, or we might have come across about some articles, especially in Bangalore, the fish, especially in Alsur Lake, the fish used to die and it used to come to the shores of the lake. And in some seashores, the fish used to die and it used to come to the seashore. Why? Why? Because as I discussed in my previous session, dissolved oxygen is very important for aquatic life to respire. So due to oil spillage in seas or due to drain water present in the lakes, the dissolved oxygen level comes down drastically in the lake water or sea water. So since dissolved oxygen level comes down drastically, the aquatic life cannot survive. So in order to find out what is the oxygen level present, we are going to determine dissolved oxygen. That is a completely different story. So what is the COD? So BOD is biological oxygen demand. It gives amount of oxygen required to oxidize both or oxidize only organic waste present in wastewater sample. COD gives amount of oxygen required to oxidize both biologically oxidizable and chemically oxidizable organic and inorganic waste. So keeping that dissolved oxygen in mind, Environmental Board gave directions to, that is Pollution Control Board, PCB, gave direction to industries that they are supposed to treat the water in their own plant, then they can connect to the water, either lakes or seas. So because of this, of course, water will get polluted, but still the dissolved oxygen will not come down and the aquatic life is safe. Now the question is, how much amount of oxygen should be, how to oxidize that? So how to oxidize the waste present in the wastewater? So suppose supply the oxygen. So how much oxygen should be supplied? That is determined by COD. So COD is amount of oxygen required to oxidize both organic and inorganic waste present in 1 liter of wastewater using strong oxidizing agent such as potassium dichromate. So I have an textile industry, so my waste will change day to day on hourly basis. So I'm going to segregate in a tank. So before connecting it to the drain, I'm supposed to oxidize the entire waste. It might be inorganic waste or organic waste. So how to oxidize that waste or treat that waste? By supplying oxygen. How much oxygen should I supply? That is the question mark. I'm going to take the sample of that. I'm going to find out COD. How to find out, we'll discuss. Okay, for 1 liter of water, how much oxygen, if I come to know how much oxygen I should supply, then for 10 liters I can calculate, then for 1000 liters I can calculate, then I can supply oxygen. Because oxygen is, I'm not getting free of cost, I'm buying oxygen from somewhere else and then I'm supplying that oxygen. So what are the advantages of COD? So by the quantitative method for measuring total organic load and inorganic load, it is more preferred than BOD because the results are reliable. In COD, both organic and inorganic waste can be treated, whereas BOD, only organic waste can be oxidized. And the COD can be determined on regular basis, hourly basis, but BOD requires more than 5 days. Minimum 5 days is required for BOD. In general, usually COD is greater than BOD. Why it is greater than why it is greater? Because COD oxidizes both organic and inorganic waste, whereas BOD oxidizes only organic waste. So now let us discuss what is the procedure to determine the COD. So in a BOD, we are going to take standard FAS solution. So what do you mean by standard FAS solution? Standard FAS means the weight of solute and the volume of solvent in which it is dissolved. Both are known by which the exact strength, what do you mean by strength? Normality or molarity can be calculated. The standard FA solution is taken the burette. So in the conical flask, 25 ml of wastewater is taken. To that, we're going to add 25 ml of K2Cr2O7. So in the laboratory, I cannot get the oxygen and scent, right? So in order to find out how much waste is required, how much oxygen is required, I'm going to add strong oxidizing agents such as potassium dichromate. Then I'm going to add 1 test tube of sulfuric acid, which is mixture of silver sulfate and mercuric sulfate. So silver sulfate acts as a catalyst which increase the rate of oxidation of straight chain hydrocarbons, whereas mercuric sulfate will prevent in precipitation of silver as silver chloride. The main purpose of adding mercuric sulfate is in preventing silver as silver chloride and maintaining silver as silver sulfate only. Indicator used here is ferroin. The chemical name of ferroin is 110 phenolphthalein sulfate. So we're going to add all those things and titrate against the FA stick in the burette until the color changes from bluish green to reddish brown. Once the color changes from bluish green to reddish brown, we're going to take 3 trials. Then we're going to perform a blank titration. So blank titration is performed here. So whatever volume you're going to get here, that is for unreacted potassium dichromate. As soon as you add potassium dichromate into the wastewater, the potassium dichromate will oxidize the entire waste present in the wastewater. Out of 25 ml of potassium dichromate, maybe 10 ml might be used, 15 ml might be left as it is. Out of 25 ml of potassium dichromate, 20 ml might be used, remaining 5 ml is as it is. The 5 ml potassium dichromate will react with the standard phase taken in the burette. Redox reaction will occur here, right? But what do we want here? We want here how much volume of dichromate is used to oxidize the waste present in wastewater, right? So I want to find out that, we're going to do a blank titration. So in the blank titration, we're going to remove the sample. So we're going to take the conical flask. In conical flask, 25 ml of dichromate, sulfuric acid, indicate everything we're going to add and repeat, we're going to get some value. So blank titer value minus sample titer value gives us the volume of potassium dichromate required to oxidize the waste present in the wastewater. So keeping that, we can do the calculation as follows. The COD of the sample is given by N into B minus A into 8000 milligrams per dm cube of oxygen. So where N is normality of ferrous ammonium sulfate, V is volume of wastewater, B is standard volume of blank standard phase consumed in blank titration. A is volume of standard phase consumed in sample titration. By substituting these values in the formula, we'll get COD. Thank you.